we got to factor all these. This one's simple. The numbers multiply to 27 and add to 12. Instead of making the list, I'm going to tell you what the numbers are. They're 3 and 9. So this should be an x. So it should be x plus 3, x plus 9. Done. Next one. 2 and 8 add to 10 and multiply to 16. K plus 2, k plus 8. Adds to 3 multiplies to negative 10. So that's going to be negative 2 and positive 5. R plus, what did I just say? R plus 5 and R minus 2. There we go. Okay, this one. We got to do this thing. So we get negative 10. It has to add to 9. So those numbers are going to be very good. So minus 1 and 10. So this is going to be 5n minus 1, 5n plus 10, all over 5. We're just going to divide the 5 straight into this whole bracket. So we get 5n minus 1 is the first bracket. The second one is going to be n plus 2. Okay? Alright. So product here is negative 50. The sum is negative 5. What are the two numbers? I think they are 10. Or sorry, negative 10 and positive 5. Okay? So we're going to go 2v minus 10. 2v plus 5 all over 2. The 2 directly divides into here. So this will be v minus 5, 2v plus 5. 8. I hope that's on the video. I guess this is on the video too. Now, believe it or not, this is a perfect square trinomial. How do I know? This is a perfect square. This is a perfect square. Square root of 9 is 3. Square root of 1 is 1. 3 by 1 doubled is 6. Which is that? So this factors to 3x plus 1 all squared. Next one. Identify the factors means factor this. This is a difference of squares because it's a perfect square minus a perfect square. So square root of 9x squared is 3x. 3x plus minus square root of 64 is 8. That's all there is to that one. Explain why this polynomial is called a difference of squares. Because it's two perfect squares being subtracted. Okay, now we have to factor these. So the first one, we're going to common factor first. We get this. What you'll notice is I've identified they're all even numbers and we can divide them all by 2. So I write down the 2, I divide every single thing I see by 2 and I get this. Then I notice this thing in the bracket happens to be a perfect square trinomial. Because the square root of 9 is 3, double that, you get 6. So I'm going to factor this like so. X plus 3, all squared. It's just half the middle number when it's like a simple one like that. And that's a plus, that's a plus. Okay? This one here, we're going to write down the 5. N squared minus 4. N squared minus 4, that's a difference of squares again. So I'm going to copy the 5. I'm going to put 2 brackets because I've identified it's a difference of squares. N goes here, minus 2 plus 2. Okay. 7, I'm going to assume fits into all these. So 7 goes there. G squared minus 10g. 7 goes into that, I believe is it 25?
Yeah. That's
Yep.
25.
Okay. Look at that. Another perfect square trinomial, because square root of 25 is 5, double it, we get 10. So this will be 7 g minus 5 all squared. That one's done. Okay. This one here, you could directly, right now, if you wanted to, I think, factor this as a perfect square trinomial. I'm going to make the numbers smaller, though, by putting a 4 down first. So I'm going to go like so. It's going to be m squared minus 16m. This divided by that, I think, is 64. Okay? So we get 4. This is a perfect square in here. So square root of this is 8. Double it, we get 16. That's how we know. So it's m minus 8 all squared. Okay. This one looks like it could be a difference of squares, but these aren't perfect square numbers. So we're going to divide both of these by the biggest number we can, which I think is 9. Maybe. No, maybe not. It's 3. So if I put a 3 here, we're going to get 9w squared minus 49. So this will be 3. This is a difference of squares, so I'm going to put 2 brackets like so. 3w. 3w. Minus 7 plus 7. This one here, biggest number is 2. This will give me 121v squared minus 25. 2. Now this is a difference of squares again. So 11v. 11v minus 5 plus 5. Okay, so when it's set equal to 0, we have to do one more step at the end. We have to tell the sheet what the values of p or x or whatever. You can actually just change all these to x's if you really want to. Doesn't really matter. So first thing we're going to do here, we're going to write 2 sets of brackets, set it equal to 0. The numbers that multiply to 52 and add to 17 are 4 and 13. So it's going to be p plus 4, p plus 13. Reluctantly, here we go. So what we're going to do now, we have to either make this bracket 0 or make this bracket 0 at separate times. It doesn't matter. So p plus 4 will equal 0. Or p plus 13 will equal 0. And this is just a simple equation to solve. You get negative 13 and negative 4. You just move the numbers to the other side. You get the opposite number every time. So that means our answers are negative 4 and negative 13. These should technically be p's, or we should just make these all x's. Okay, just ignore that. It's a typo. Next one. We have to factor this. So we do this. We get negative 68 for our product. Our sum is 13. The numbers that multiply to negative 68 and add to 13 are going to be, I don't know. So 1 times 68, 2 times 39, 3 times nothing, 4 times... Is it 4 times 17? That works. So we're going to make the 4 the negative, because then when you add them, you do get the 13. So 4x. 4x. 4. Minus 4 plus 17. Our final answer will be x minus 1, because we divide the 4 into both of those 4's there. And then we have a 4x plus 17. Now, this one here should give us an answer of positive 1. Because 1 minus 1 makes 0. I'm not even going to write that out. This one here, I'm going to write it out one last time. 4x plus 17, we want it to be 0 because we had an equal 0 here and here. So it's 4x be equal to negative 17. X is equal to negative 17 over 4. This pattern, every time, it will be the opposite of this number here. So the opposite of 17 is negative 17 divided by 4. Negative 17 divided by 4. So I'm going to write negative 17 over 4. I don't care what decimal that is. Just leave it like that, whether you like the fraction or not, just leave it. If it comes up to a clean decimal like 1.5, I don't have a problem with you writing that, but why do more work if you don't need to? Okay? So next one. This one, we're looking for two numbers that multiply to product of 42, and the sum is negative 13. So the numbers are going to be 6 and 7. Okay, good. So we got 3r minus 6, 3r minus 7 over 3. The 3 goes directly into both these numbers. So this will be r minus 2, 3r minus 7. Now that we have this, we're going to take the opposite of this number is 2, divided by the coefficient of 1 is still 2. So our first answer is 2. Our second answer, opposite of 7, or negative 7, is positive 7 over 3. So it's just the opposite of this divided by that. That's it. Okay, here we go with some word problems. First thing you want to do is copy down the equation so you can work with it. Notice the first thing I did was not read this. The reading, that will come later. Okay, an arrow is fired from a platform. Great. Its height is this. H is the height, where T is the time in seconds. H is the height in meters. They want to know the length of time the arrow is in the air. I'm going to write down here that we're going to assume it starts at t equals 0. So if it starts at t equals 0, from 0 to the time it hits the ground will be the time it was in the air. If we get that it hits the ground at 8 seconds, it means it's in the air for 8 seconds. Okay, so in order to figure out when it hits the ground, we have to tell the equation that we would like to know the time when the height is 0. So we put 0 in. We factor this now. Negative 5 t squared minus 10 divided by minus 5 is minus 2t. 40 divided by minus 5 is minus 8. Now we have this. Negative 5. We're going to factor this thing. How do we know that? Well, it's the only tool we have right now is just to factor it. So two numbers that multiply to negative 8 and add to negative 2 are negative 4, I like, and positive 2, I like. So now, our answers here, we can't turn that minus 5 into a 0. We need to turn the whole side into a 0. What's the answers?
T equals positive 4, t equals negative 2.
Yes, so I'm going to say t, the first time is positive 4. The second time is negative 2. We don't care about this one. Don't care. We care about this one right here. So our last thing, it's in the air for 4 seconds. Okay, next one. Professional blah blah blah. Here's the equation. Seriously, that's how you want to read this. Blah 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 equation. What was the height of the cliff the diver jumped from? Okay, now you can go back and you can say to yourself, well, there's my equation. He jumped at time 0. So the answer will be 36, because when we put 0 in for t, it's negative 4 times 0 squared is 0 plus 36. So I'm just going to write here to remind you guys, h of 0 is equal to negative 4 times 0 squared plus 36, which gives us 36. So the answer is 36 meters. Okay. The x-intercepts now. X-intercepts are when the height is 0. So I'm going to go ahead and I'm going to put 0 in for the height. Negative 4t squared plus 36. Now, easiest way to factor this is going to be common factor the negative 4 first. So we get t squared minus 9. Now I'm going to go up here. T squared minus 9 is a difference of squares. So we have 0 equals negative 4, t minus 3, t plus 3. So our answers here, t1 is equal to 3, because 3 minus 3 makes 0, and the other one will be t2 is negative 3. Again, don't care about the negative time. So wait, that is the x-intercept, so there they are. When will the diver reach the water? The water we assume is at ground level or 0 height, so our answer of 3 will work there. So we're going to say at 3 seconds. Last question on here. It says the path of a football can be modeled by this function. Now, there's a typo here. This should say h of d. So what we're going to do, how far down the field does the football travel before its first bounce? Don't think of this as something that's bouncing and bouncing and bouncing. It hits the ground. We don't care about anything after that. We're going to assume it bounces, but for all we know, it could just stick itself in the ground and stop when it lands. Okay, that's all the equation's going to give us. Anything beyond that is second or third year university math to model a projectile bouncing. Okay, so first thing we're going to do, as usual, is just copy down the formula. Negative 1 over 16 d times d minus 56. So, believe it or not, this is already factored. I'm going to put this into brackets like this for a second. It still doesn't look like factors form. What's that? Okay, so what would make this bracket 0? What number for d would make it 0? Well, 0 is the only answer that would work there. So at d equals 0, that would be our first answer. That's the first time it's at the ground. So wait, that's when they kick it. So when the ball is 0 meters away from them, they kick it, and then it starts going. And then, what's the opposite of negative 56? Well, that's d equals positive 56. I should have really put 0 equals here to say, okay, when the height is 0, we get d equals 0 and d equals 56. So, here we have it. Here's the football. The person comes and kicks the football here, blah, blah, blah. Here's d equals 0. So he kicks it at this point when he gets here. He's 0 meters away from it. He kicks it, and it lands 56 meters away from him. Okay? And if we want to know the height, if we were to put 56 in here, we get 0. If we were to put any other distance in, like 50 meters, we would get how high it is at 50 meters. Okay? Now, what I want us to do here is it wants to know the maximum height reached by the football. Well, the middle of these two numbers is 0 plus 56 over 2. This is how you compute your average. If you have a 0 and a 56%, your average would be 28%. But in this case, we're talking about meters. So at 28 meters, we should get our maximum height. The question is, what is that maximum height? Well, we're going to say h of 28 equals negative 1 over 16. times D, which is 28, times 28 minus 56. So you get negative 1 over 16 times 28 times negative 28. And if we work that out, can anyone just yell out the answer for what you get for that? Okay, equals about 49 meters. How far down the field is the football when it reaches its maximum height? 28 meters. 28 meters.
Wait, can you spit it?